Good afternoon, everyone, and thank you very much for joining us for the very last webinar of 2025, Systems Approach for Mass Timber High-Rise. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note that the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions you may have for our speaker there. Questions will be addressed during the designated question and answer period at the end of the presentation. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please allow just a few weeks for the processing and reporting of these hours. And lastly, please note that the presenter does not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, with that, I am very excited to introduce our speaker for today's session. Please welcome Oliver Lang.
Good afternoon and welcome everyone. Thank you for joining this session. As Shalika mentioned, my name is Oliver Lang. I'm the founding architect of LWPAC Architects. We're based here in Vancouver, but with increasing interest also in Ontario. And I'm also the co-founder of a company called Intelligent City. I've spent the last 2 decades of my career working on how to transform the housing industry, addressing some significant issues that we're, I think, collectively facing, with a specific focus on the use of integrated technology platforms, prefabrication, mass timber, and so forth. Before I go into further detail, Shalika, just wouldn't mind if you could launch the poll. It's always very nice when you speak virtually to know who you're speaking to. So if you don't mind providing a quick answer here on the poll, so we know where your backgrounds are, and that helps me also to slightly adjust the tone of this presentation. Okay, that is very clear. 99% architecture. Okay, great. Good to know. Thank you very much. Appreciate that. So as mentioned, the title of this presentation today is Systems Approach for Mass Timber High-Rise. I'm looking at it very much from an architect's perspective today. Of course, I have many times talked about it from the Intelligent City perspective over the years, but today I really want to speak a bit more about what all of this could mean for us as architects, what it meant for me. And I want to exemplify it on a project that we're currently building in Toronto at 230 Royal York in Etobicoke. That project is the tallest mass timber residential building right now. It's a 9-story, 43,000 square foot building with 60 rental homes. Will be Ontario's tallest mass timber residential building as of now. And we'll look together at why this project we think matters, how integrated design and prefabrication comes together, and what we can learn from this for scaling sort of more carbon neutral housing across Toronto and beyond. What we'll cover overall, or what I'll cover here, is the project and the team, and provide some background. How did this project even come into being? Because it does require a lot of courage from all parties to do something that's new. And what that also means for architects sometimes to engage yourself in something that is new. Why mass timber matters, I believe, for housing now. What specifically LWPAC's design integration approach was be, what that meant to collaborate with intelligent cities and their building systems and their manufacturing approach. Some effects on overall schedule and carbon outcomes. I can't share too many details of cost on this, while I all know that you would like to hear those, but they all remain often confidential. But in terms of trending, I can. And then, of course, overall sort of lessons learned about what we have accomplished as a team here so far. Some acknowledgement to the OAA. Thank you very much for the invitation. I think the continuing education efforts are really important, that we as architects have a platform for discussion. So please also reach out afterwards if you want and have a continued conversation. We really think we're all in this together, and we need to solve some of these significant problems that we're facing together in teams. And I think project teams and the way how we collaborate will also change. And as you will see in the presentation, LWPAC is also available to work with other architects. And so, of course, is Intelligent City in a number of different ways to help you transition into this market if this is of interest to you. We're grateful to our project partners and collaborators, the communities, and of course, the traditional territory of many nations here, where this project is hosted, need to be acknowledged. For this project, of course, the biggest shout out goes to the developer itself. Windmill was working together with Leader Lane Developments, and without a visionary client, it's really impossible to do a project with this ambition. It came out of a 5-year conversation that I initiated together with the CEO of Windmill and founder Jonathan Westlinde, and really having a discussion about how we can change some of the paradigms around housing. The involvement of LWPAC Architects as the design and AOR, their design architect and AOR for the project, and then the mass timber building systems here manufactured and supplied out of the factory here in Delta, BC, by Intelligent City. The structural engineers, Moses Structural, and the builder Openbuild all played a very, very key role in the success of the project so far. Going back to stepping back a little bit, like what are the main issues? And I think many of these you're fully aware of, but nevertheless, I'm going to just repeat them. That we believe housing is one of the largest unresolved challenges of our time, because we need a huge amount of housing and we're not catching up. We also haven't really seen any real productivity gains in our industry for far too long. We continue to build bespoke buildings instead of looking at scalable solutions. And then we have an industry that is responsible for almost 40% of carbon emissions, which you all know, these data points have been around, but the paradigm hasn't really changed all that much, and the problem remains the same. And then we have rising costs of constructions, but increasing labor shortages. There's a bit of a dip right now, and construction costs have maybe momentarily come down a little bit, but I think that's going to be all erased within a year or so, and then we're going to really face the labor issues even more so. Projects are, as I said, too bespoke, which leads to change orders and often sometimes chaotic scenes on site. Many people tripping over each other, trades not being there and walking away from sites and drawing out construction timelines. With long-term asset holders that in the market that we're in as architects right now, where we really almost exclusively work with rental housing developers who really have a close look at what asset they're built and what it might be worth in 5 or 10 years. ESG requirements are of importance, and because they know if they ever want to divest some of these assets from their portfolio to, let's say, pension funds or the likes, they're going to have a very close look at the overall ESG profile of a project. And then the issue of the high financing costs. So they're all compounding each other and make it very difficult. So response that we have developed at LWPAC, and again, this lecture, they're very similar if I would speak about it from the intelligent city perspective, but I want to focus a little bit more on the architect today. So as a practice, we really just decided a long time ago, even before spinning out Intelligent City as a company to manufacture components, that we need to find scalable, more affordable, and sustainable solutions, obviously, and do that by using a much more integrated design engineering approach overall. And that's really, it's start to change the way how we, what areas we have in our company, how we look at projects overall, feeling we're becoming far more product designers than being providing architectural services on a one-by-one project basis, even though by contract and applications and entitlement process, that's still needed. Our approach to this is really looking at how do we create underlying principles that could hold true across a whole number of projects. So working with one coherent technology platform, combining mass timber as an architect, really, I think increasingly sophisticated process of BIM, AI, computation, and so forth, all of that really being part of the practice that we're using. And then that creates a sort of continuity in a company like Intelligent City that can take the data points, can exchange them flexibly as a manufacturer with an architecture practice like ours, and then go from there and provide all the way into robot code and robotics and so forth as one real continuity. So as a practice, as an architecture practice, we're really thinking of ourselves as part of this sort of newer continuity. How do we go from design and entitlements to all the way into manufacturing issues, and enabling manufacturing issues, and doing that through the use of manufactured products out there. And as a company, we don't use, even though I'm the co-founder of Intelligent City, but we also do projects where we don't use Intelligent City, even mass timber high-rise buildings now and in the future. It really just always depends what the right product is. So, we're born out of the same group of people, but we're really two legally completely separate company. And LWPAC Architects also works with other mass timber suppliers, and Intelligent City will also and is working with other architects. So just to be very clear, it's two entry points, legally separate, but a lot of lessons learned through the collaboration, obviously. So in Intelligent City, really, that was taken further, and then really the sort of product platform approach that there is large scale componentry like a mass timber curtain wall and a mass timber structural system has been developed from a consistent way of manufacturing. Stepping back a little bit, some of the motivation I think that also led to the 230 Royal York project was sort of a discovery some time ago about the right-of-way zoning context in Toronto, that there has always been a height allowance along these arteries that we thought was actually really interesting to us for some time, sort of urban densification of unused sites and potentials without land assembly necessary, and quick zoning approvals. That's been something we've been pushing for probably for a good 15 to 20 years right now. And so when we came across this, we thought, wow, there's some real potential. And we're really delighted to see that the City of Toronto has made progress in providing policy around the avenues so that we can have a consistent framework. And it creates a sort of sweet spot of, 8 to 12-story buildings along the arteries for which light frame wood doesn't work, and concrete doesn't make really much sense. So it's actually almost ideal for prefab mass timber as a scale, and that is also where the 230 Royal York project is located. So this idea to do something that's scalable and repeatable up and down the arteries was really important to us, and really sort of sparked interest also with our client. So when we started the project in discussion with Windmill, They came to us and really talked about that they wanted to create a new brand. The project was originally meant to be for condos, then was later converted into a rental building. But the brand ideas held true, which was just to create a building that's very much about urban living, good urban living, sustainability, healthy living, good experiences, and good quality overall, right? That people can perceive that will provide added value to the owner and operator and equally to the tenants. And so Windmill had secured funding through the One Planet Living framework, in which some issues here, like health and happiness and equity and cultural community and so forth, all of these really, really matter at these points. Use of materials, carbon overall. So the building from the beginning had a requirement to be LEED Platinum and get to not it's not going to be Passive House certified, but it's essentially Passive House equivalent in terms of the building envelope overall. So very high standards from an envelope and well-being perspective, also through the funders for the project, which was really important. When we started the project, we didn't just look at one, we looked immediately with Windmill at multiple sites, and sort of looked at if we create a brand, how do we not just do the sort of the one bespoke, but rather how can we come up with something that works principally across multiple sites and multiple projects, can speak to the ownership, the brand, the look and feel of the building. And this is just a sort of like, an idea of a certain patterning. And this is one example. We did the same for floor plans and massing and so forth, right? And showed them that with the same kit of parts, you can create a significant variation, right? So patterning, environmental issues that are sort of patterning the layouts, the units, the look and feel of it all as something that then you could sort of almost like choose from a menu like you see on the left there. What type was it? Does it have retail on the bottom or not? What's the layering up? How does it fit within the site plan approval issues and setbacks? We had a lot of discussions with the city of Toronto. How can we fit that in without making things unnecessarily complicated, right? So the city of Toronto has reached out to us a while ago, probably even as far back as 3 or 4 years ago, and asked, where are the issues with prefab? So we told them a lot about the sort of setbacks that, the so-called wedding cake, that how that makes things really, really complicated, but we need clear building forms, but then that we can still have a significant amount of variation in articulation. Like in this building, initially it was designed with all these balconies in front. Some of the balconies were eliminated for just simply cost when we went to rental. But it was still good for us to see as a study overall when we deliver that across the arteries, and when the condo market comes back alive, that we have that. It forced us to really think about how do you do balconies in a passive house building, how do you create connections. So we retained the upper floors for the top level units and the community amenities in the building with this articulation. A lot of discussion about when you do sort of prefab solutions and along the urban arteries, what's the ground interface of this in terms of materiality and landscape? It's very, very minimal what you can do there on, particularly when you're on zero lot lines. And then expression, architecture expression, there's always this concern. You do prefab, do your buildings always look the same? Where can you animate a building and where can you not? And prefab has a set of fairly strict rules on one end, but actually provides a surprising amount of flexibility if you get used to playing with those rules. So the outcome of that process is what's currently being built. It's almost topped out and almost enclosed now. Is this building here where we have 43,000 square feet, 60 rental units, range from studio to 2 bedrooms. It's a 9-story building within the Toronto right of way. It's all built from mass timber, so both the floor system and the enclosure is that mass timber curtain wall. And it's a hybrid building, and it's that the core is concrete, and you can see that reasonably well here. So concrete core, but all the floors from level one up. So only the slab on grade is concrete, and then the floor is level one, so above the retail already, and the replacement units in the back of the house is all mass timber already, all the way to the very top. Very, going back and forth quite a bit with the alignment of the apartments to the layout, and then as I will show, a lot of time spent to really look at questions of integration, right? And this is really the key role of an architect in these projects. It is just not enough to provide a design and declare intent, and then so let to some extent let the builder and the trades figure it out and provide feedback. We as architects now provide really pretty much everything on the building that we can, down to the finest grain on the specifications and all the detailing, all the fully, integrated BIM models and so forth, so that we can have these systems in the mass timber, in the connection to the cores, in the connections to the balconies, as it's shown here. So this is how it looked like at the after a few weeks of construction, but this is a good picture sort of to get a little bit of an overview when you have a prefabricated system of this kind, what you're dealing with, a lot of thinking about logistics and so forth, that I will talk some more. Stepping back one more time, we also look at these projects obviously as collaboratively as architects, as engineers, as builders and manufacturers, as regulators, and developers, obviously, to create a more integrated Canadian housing ecosystem, creating incentive for supply, which is increasing, and also creating demand by creating these kind of demonstration projects that we hope, of course, to repeat many times. And then, been working for years together with Intelligent City to make sure that the kit of parts is not restrictive, that you feel there's only one way of building. As you can see, all these little images here, all buildings you can do, be that as single loaded or double loaded buildings with atria or courtyards, or again, with two core, single core, high rise type of a single core. All of these are completely possible with a system like this. That is all baked into the platform, so that we can meaningfully sort of densify the cities, get to build good buildings close to rapid transit, to good walkability in urban environments. That all the systems are always designed so that it enables mixed use. So you can have on the bottom, you can have these podiums, and with retail or other functions, community functions, and so forth. There's a categorization in this. Obviously, up to 6 stories is a light frame system that right now LWPAC is working on a couple of projects right now. It doesn't use the Intelligent City system yet, because that was designed more for high rise, but I believe there will be something coming in the future. But there's obviously a great interest for us as architects on the 3 to 6 stories as sort of a meaningful way of densifying, particularly with the kind of cost sensitivities that are out there. And then, I think a fantastic market in 7 to 18 stories right now, where we have now just, completed the erection of the second building, and have exciting other projects to come. So why are we doing this and moving into this idea of prefabricated systems approach? Because we can deliver repeatable quality and performance, and we've proven that to ourselves and others now. We can move work into a controlled factory, so we can become seasonally much more independent and get completely different quality control, use industry sort of 4.0 as an AI and robotics and so forth. And I'm sure you've all played with AI in the past, in the last few years, and see how incredibly powerful that is as a tool. Reduce on-site labor and weather risk, as I said, and then dealing with ESG issues and get to more predictability. So de-risking is a big part of this approach, for our clients, is that we can get them more predictability. And a first project, there are always a lot of lessons to learn. But once you've learned those lessons, the nice thing when you take a systems approach is in the repeat, you don't repeat the mistakes, versus in bespoke projects, unfortunately, a lot of mistakes get repeated. Um, so here, with the Intelligent City platform, where you have the building systems, you have the robotics, and then you have an underlying software, uh, you know, understanding that as architects, we will also just, of course, ask ourselves if the industry transforms generally into this combination of further automation in the manufacturing, more building systems, requires simply more output. And therefore, the products that will be delivered to us as architects require a certain amount of repeatability and have certain parametric logics, right? How wide can you go? How deep can you go? How far can you span? What loads can it take? How does it work with the MEP integration in this way and that way? This is rules based. And so as an architect, we had to force ourselves to change our architecture practice to understand that rules-based approach so that we can interface with mass timber manufacturers overall and those who make systems. That's super important. You have to understand really what the manufacturing issue entails, what limitations it might have, but also what incredible benefits it can bring to help de-risk things, to have quality control and so forth. So as an example, you may think it's risky as an architect to work like this and adopt and doing like a first project of this kind. Well, we have now, Intelligent City has now installed over 300 mega panels. With mega panels, we mean floors that are like, up to 13 and a half feet wide and 40 feet long. Facade panels are 10 feet tall and, almost 30 feet wide. So we've installed over 300 panels and every single one fit with millimeter accuracy, right? So it's actually less risk to use something that comes out of a quality control platform, particularly also if it's certified. Um, there's the whole issue of affordability, and I'm boring you an image to credit to one of our current clients, um, where if you can get costs down and through repetition, we can show, we have proven to ourselves and others that we can bring the cost down through repetition of projects. And that also means that if you have repetition if you have these sort of compounding effects of lower rental rates versus what's happening in the market. Affordability doesn't just come down on day one. It actually comes down if you only need to increase the rents by 1.5% or something in a building versus 2.5 or 3%, then the difference in 5 years is very significant, right? So to find a way to reduce the operating cost, to reduce the construction cost overall of the building can have a really significant effect on affordability. Um, we are in an early phase right now. There are a few, and I don't think mass timber is a novelty any longer, but we're still in sort of a kind of catalyst phase, again, to borrow the terms of one of our clients here, and we're trying to get into a growth phase. I think we'll be able to demonstrate it now that these systems really work. And that we have also significant benefits on the speed and scalability. One is the obvious parallel on-site, off-site construction, but also just simply how quickly these parts can come together. And what we're getting now into, which becomes increasingly interesting, working with different cities across the country, is if you have that level of consistency and trustworthiness on the systems, even on building permits and so forth, is that your approvals will be faster, right? And so we're trying to, you know, get the cities understand these buildings and what a repetition, if it's 95% identical, then why would we have that much more time? I know that sounds like a wonderful dream and the cities are complicated, but I can share with you that we are having these discussions with the various municipalities in across the country right now, and hopeful that this will lead to significantly faster approvals. What we already see is just regulatory framework, like in BC, in City of Vancouver, everything gets sort of pre-zoned, and now what you can develop your products for, and therefore you don't have to go through lengthy rezoning processes anymore. And that will help. So you can accelerate really on a number of different fronts. All of that will really help to speed up the project, but importantly, and that is the challenge, if I go back here one more time, with the mass timber industry, is it can work extremely well to bring costs down and bring acceleration to the market, but we are increasingly just interested working with owners that have a portfolio approach, that don't just come with one building. Let's try it out, do a demonstration project, learn from it, give a grant. That's all nice, right? But what really is needed in our industry and where we're going right now is finding clients who want to do, two buildings a year or one building a year or 10 buildings a year, but really take an approach where we get that repetition because the entire approach right now with what's being pushed right now from the Prime Minister through Build Canada Homes, etc., it just requires much more consistent demand on the factories, on the manufacturers, and otherwise we keep restarting the same engine, right? So I think that's something I think where we as architects can play a very important role is to help design, work with our clients, make them comfortable on this approach, and in return, we actually have less liability, quicker turnaround, much better quality product overall. The carbon issue is important. So we've done extensive studies. We've had that confirmed. We've sent that out to experts in the industry repeatedly through Intelligent City that if you consider the behavioral, the operational, and the embodied carbons on a building overall, let's even take the behavioral out, meaning less cars, more people walking and biking. Look at just at the building in terms of embodied carbons, replacement because you use the mass timber instead of the concrete. You have all that sequestration in the timber. And if you design the building properly in, like, say, a passive house enclosure, that wood will last a long time. So you just don't need to demolish the building after 100 years. Like, many of you have probably been to Japan and seen these 1,000-year-old wooden pagodas. If wood is kept in a consistent environment in terms of temperature and not exposed to moisture that can lead to rot, but actually just being properly detailed around. There's no limitation to its life cycle itself. And then you have the operational issue, so really dramatically reducing the environmental footprint on this building in 230 Royal York. It's got geothermal in it, and therefore also significant, then the passive house enclosure, so significant reduced energy needs. And that brings the overall operational footprint significantly down. So before I go into some more details, quick background for 15 minutes here on LWPAC and Intelligent City, and then I go into sort of the lessons learned before we can go into some discussion. So we've been around for about 27 years right now. We're really always focusing on technology development, really driven by that for a long time, and that led us to really look at housing, prefab, and mass timber. Have been research driven, sort of flying under the radar, I think, for a long time and really done a lot of R&D, and always been interested on this relationship between architecture, technology, systems, and the cities, and done projects, even as sort of like a small mid-sized practice on, here in South America and in Asia and so forth. And been really working on how can we build better housing, how we can make things that are sort of timeless, scalable, they're designed for well-being, comfort, connection to nature, longevity. Um, Very interested in this whole question of biophilia, and you see that the 230 Royal York has most of its mass timber exposed. We've been really pushing that on most projects. We really believe it has a profound effect on well-being. Make sure the buildings in an urban environment are quiet to live in, but also quiet to build, that they're just good neighbors, right? And using prefab systems like this, it is amazing how quiet these construction sites are, how few people, how few trucks arrive, come and go. So it is that sort of holistic thinking about creating a building and then have people living in it, creating great jobs from that, and do something that's ultimately, resilient, more long-term focused. That's sort of the core essence of the architectural practice. We want to we want to shape a better way we build. That's sort of our mantra. Um, have been interested for a long time on this question of the avenues, and sort of build as a first building that then into where LWPAC couldn't find the componentry as an architect. We just kept designing buildings. Who's going to make these buildings for us? And we couldn't find that. So in 2008, we spun out Intelligent City as a manufacturing company. to deal with these sort of urban arteries that we thought were sort of prime, ripe with, single story mom and pop shops and just all that residual density, wonderful infrastructure, bus line, trolley lines, community centers, libraries, everything was there, but completely underutilized potential for densification. And so we started out in Talon City to address that. And the 1.0 version was really a factory we had for volumetric modular construction. So, first buildings were built into that kind of scale. And that, if I fast forward, sort of projects on the go right now, one downtown Vancouver, another nine-story building that's going through permitting right now. Passive house, nine-story, 52 stories, lovely building with a courtyard configuration. That's moving forward. And then all the way up to a project we're working on right now that just got council approval a couple of weeks ago, 18-story building, 221 homes. It's a hybrid structure, so it has concrete core and a hybrid mass timber steel structural system. Um, it's a three-story podium for parking and retail. That is built in concrete. Kelowna has particularly bad soil conditions, so you can't put parking below ground, but there's a minimum required. But a nice sort of side story here for mass timber is we got a very significant variance approved from the city of Kelowna. Requirement on this building was 180 parking stalls. And we said, because we're building in mass timber and we're really changing an environmental paradigm, we got away with 48 stalls. City of Vancouver, for example, now offers 2 to 3 extra stories of height and density during a rezoning process if you are doing a mass timber building. And then additionally, there's also up to 15% additional density if you do passive house. So there are benefits increasingly. It's been recognized. The municipalities want it, right? It's better. It enables faster solutions, as I said. It makes quieter construction site. It creates good jobs in the environment and so forth. And then where we also work together and where we don't, right? So that's just, again, to repeat that and to be clear, two completely separate companies founded by the same group of people, but really have very different ownership. At this time, after the Intelligence went to many rounds of investment, as very diversified group of owners now. Um, and LWPAC being, has its ownership structure, and the companies work together because they know each other extremely well, but they also do business completely independent. So any of you, please, reach out to Intelligent City. I'd be delighted to work with any architects out there. And equally, if any of you architects are looking to have a collaborating architect in some form because you haven't done mass timber and you want somebody who's really extremely knowledgeable, let's reach out to LWPAC as you see fit. Um, so the LWPAC really focuses on the urban design, architecture integration, entitlements code, but also the detailing, the sort of new model of practice. And Intelligence City really produces the building systems and the envelope, the enclosure. But as a collaboration here, a proposal we did with one of the Indigenous housing societies waiting for funding, like many projects currently waiting for funding in Canada. We provided a proposal of 4 buildings, almost 1,000 homes, ranging from 15 to 18 stories, 4 sites that Indigenous housing group owns in and around Vancouver. And so that's something that, where you can, when you have this systems approach, you can provide a high degree of certainty on costing, constructability, and so forth. Designing for prefabrication really is absolutely key for success, right? You can't just design a building and design it for concrete and then think, oh, let's price it in mass timber. Often it's too late at that time, right? So if you want to go down that route, I think a lot of good advice can be provided right from the beginning about sort of cost and carbon and duration and build the team. Again, both companies totally happy to assist you in either way, depending on what stage you're at, to get that right. And really understand that, what sort of grids you work in. Any unnecessary geometry complexity good prefab is really an exercise in simplicity first, and then second to then understand your opportunities to customize and make things happen within this sort of new set of rules that comes out of a systems approach. Around the unit layouts, which is a lot of flexibility, like the system that you see here is essentially point supported, and you can almost lay out the homes as freely as you want. You can even change the layout during time. You're only stuck with some locations where your vertical shafts go and so forth, but otherwise you'll have significant flexibility in this approach, and obviously, being able to come up with a set of details that you can reuse then in another project is important. Um, Issues of concern, of course, me as an architect, signing and sealing for these buildings are life safety. Number one, obviously, you're dealing with a product that it's generally not really combustible as mass timber has a fire rating on it, right? But you have to be nevertheless have to have a clear understanding about all the fire stopping, everything that goes in there, and the acoustic performance, the moisture management issues. All of these are very, very important. Um, how and what needs to be done during construction. You need like charged standpipes, for example, while you build up the building, and then how it gets assembled and how the parts come in together. I think that's very important. Integration is the biggest thing that if you haven't done a mass timber building before, you have to design. It's not enough to rely on your mechanical engineer or structural engineer. If you don't take charge as an architect to really understand exactly where the electrical runs, where the sprinklers run, where the mechanical goes, where the collisions are. So in LWPAC architects, we have the full digital model. We model absolutely everything, every location of every pipe or everything, and make sure that you cannot fix these mass timber buildings on site. You cannot have a trade show up with a drill and saying, "Oh, I've got this pipe wrong, and I'm going to go through all of this right now," and I do that in every single unit. It's just not possible. So you have to figure it out in advance. That's a commitment you have to make. That's something I think you need to discuss with your client. That if you just go in at your standard architectural fee, um, at your first building, you need an additional allowance either to bring in a partner architect or mass timber specialist who can help you with that, or you need to have a budget of the extra hour. Otherwise, you'll be surprised how much more work it is. But once you've done it, that's the key thing. You have really a systems sort of library of solutions, right? So this idea of really understanding the structure, the MEP, the manufacturing is the software issues, the people, the trades on site, that you don't have 40 people on site, you only have six, right? And the staging, all of that needs to be designed into overall a building, and then understand the differences between, are you going with systems up to 6 stories, up to 12 stories, up to 18 stories. Every single one has different regulatory requirements. And in the systems approach, that is even more profound than, let's say, in the commission of a bespoke building. Intelligent City, as I mentioned, was really founded on the idea of to industrialize housing, combining mass timber prefab and automation, creating sort of an integrated product platform, and go to the certainty of a CSA platform. So over this 18-year journey, it started off with multimetric modular, then developed all the systems technology, got to full CSA certification for the facade and the floor systems, then gone through a ramp up of building the first buildings, and now is working on scaling up a number of projects. So industrializing urban housing requires really, building up an ecosystem of architects, engineers, developers, builders, manufacturers, all together right now, and have a kit of parts that can sort of work in that scale. So a couple of quick words here about the system that was used in 230 Royal York. So the building envelope system is a mass timber curtain wall, high performance, passive house equivalent, has an integrated air, water, and insulation layers, is tested for air and water tightness and seismic movements through the CSA to A277 equivalency. It is a curtain wall, so it's got a full mechanical gasketing solution all around. It's a timber curtain wall. compatible with a number of different structural systems. You can hang this also on a concrete building if you like. It's passive house ready. Here, very simple layering, and sort of, because it's sort of architects inspired. We want it to be materially efficient and also have flexibility. So you see that you have a top and bottom beam. Then you have fill of CLT that gives it both strength, but it also means we don't take a big CLT panel and cut holes, which would be very wasteful, but rather have a system like this that is more efficient. And then you can move the windows left, right within that framework. You can have two windows, three windows, one window, whatever you like. So a lot of flexibility there actually in window placement. It's all been designed to work really well with the structural system. And you can see here in the detail how it hangs on the edge of the floor cassette. Like a 28-foot wide panel will have two load anchors and two wind anchors on it. And they are installed typically anywhere within 15 minutes, 30 minutes time from the picking up on the truck to it. And you also have, and I can zoom in here for a moment so you can see it better. So you have a fully gasketed solution here. The timber is on the warm side of the building. The membrane is on the outside. You have up to 8-9 inches of insulation, rain screen solution, and a metal cladding on the outside. There's always like a quick mock-up is done, but again, we've now done so many tests and so many mock-ups, and now we've installed over 200 of these panels. Every single one fit exactly as planned. And they all sealed nicely. That one project that we just completed here, the Chief Leonard George building in Vancouver, just went through and without really any issues, passed all the testing for the passive house requirements. And so it's really a new kind of product where you have this certainty that it will work, that it will pass the passive house test, and that the moment you install the panel, the seal, air and water tightness seal is instant. Same with the floor system design as a cassette, really inspired by the idea of leaving the mass timber exposed, not have a really clean architecture, no drops below, as cleanly integrated as possible. Use the cavity both to reach larger spans, so it really works like a big box beam, right? So you can have it point supported and still span. Significant one direction or the other, have pre-installed electrical, if you like mechanical. We don't put sprinklers in there. We don't want wet inside. And structurally very sound to also integrate as a diaphragm. So in this project here, there's really no steel perimeter needed at all, neither to support the timber curtain wall nor to reinforce the building. So you can just simply use some steel struts on top and tie them back into the concrete core. And that's the solution for the building in terms of lateral support. You can get significant spans, 13.5 by 16 feet. The panels can be made as long as 40 feet. You see a cross section here right now. I think one part that we've really been pretty excited about, both on the LWPAC and the Intelligent City side, is this connection on the bottom where you see that the lower part of the CLT goes right to the grid line. And so when that is installed on site, you have literally a millimeter accurate connection that can be easily fire stopped from the top. And then you have these ribs that are set in slightly, and that gives us the possibility to run all the services on the grid line. And you can get in there and then do the little red areas show how that then gets filled, and a little spline is put on top. So very, very simple, elegant system. Fully tested again, 2-hour equivalency. And that is why in this project we can leave the mass timber fully exposed, because we have that in the CSA certification. Just a quick idea here, this is how the panels would go in. So you really have just a few panels, 12 panels on the floor that can be installed. These floor cassettes, you can really install all of this in a day. Then you go the next day where you put the columns up, you put your shelf angles on the concrete core, and then you put the floors in that coincide with the layouts. One interesting side note, because it was designed for urban infill, that the zero lot line walls can be done no problem with the system. You get basically you drop one of these facade panels in and give you 1 hour's fire separation instantly the moment you place them. Balcony solutions were considered. That's a big issue, a big request. How do you do it thermally broken? And what we do right now is we really sort of stand them in front and have an integration detail that makes it more cost effective, and that's what you see is being done on the top two floors here. So this is how it looks on the inside, just an open column grid. You see these spline lines down on the bottom where the surfaces pop up. So much has already been installed inside the floor cassette, and then it's tied together and sealed off. And so all the surfaces run then essentially in the partition walls, demising walls between the homes, and that can be adjusted, pushed front and back as needed. And the ceiling and the end walls remain exposed all the way to completion. Um, Quite a bit of flexibility when you in a systems approach. You really work through that with the manufacturers, particularly with the sort of company, the Intelligent City, that really wanted this customization, possibly from day one, that you can have different cladding patterns, different window patterns. The windows don't have to necessarily align. I mean, you want repetition, otherwise you make it too custom. But if you can have three different, panels and play with them, you'd be surprised what kind of amount of variations you'll be able to achieve with this. As I said, the manufacturing all depends on data. Good data in means good product out. And if you can produce that as an architect, and you have that really good BIM models that are designed, and you have built sort of libraries from there, or you have brought in partners that help you build those, then you will be successful. If you have just essentially drawings and then hope that somebody's going to figure it out for you, it will either make the project extremely expensive and very custom, or it will make it unsuccessful. Again, understanding that certification is possible, I think for me as an architect, that has always been critical, right? That these parts don't need to be inspected on site. They all get shipped to the site. They have a little sticker on them and say CSA A277. That makes approvals much easier, but it also means that the manufacturer is committed to quality control. And if you buy from a manufacturer that has CSA's A277 certification on their components and on their plant and on their manufacturing, they're held to a quite high standard. And you can typically, and I would always recommend, go to the manufacturer and ask them to show you what they do to record the manufacturing process. So at Intelligent City, depending on the component, there's up to 200 to 700 quality control things checked, and everything is recorded, photographed, notes are taken, measurements are taken, and then permanently recorded. So if you go back 5 years later and want to know there's something with panel 5 on level 8, what was there, all of that is available, and you can review it all and so forth. So all of that helps to create a lot of certainty. And then robotics and automation is not just an interesting thing of our times. It really helps, of course, to speed things up, but it also allows to simply make things that you can't make by hand. You just can't get that level of precision done with doing it by hand. The application of glue and fasteners, simply the consistency, so that as an architect you have the peace of mind that whatever gets installed comes from the same process. If you want to get into systems, you can of course have somebody machine a piece of mass timber 5 ply, and that's good, right? And again, LWPAC uses that on other projects as well. But if you want a systems approach, robotics helps not just with speed, but it helps with accuracy and consistency and quality control, right? So there's something there where you can measure exactly how much glue has been used and does it have been applied correctly, how a part has been milled specifically for this project. And it is still, even though I've been with this for so long, it's remarkable to see a 30-foot component arrive on site and fit within a tolerance of 1/8 of an inch. Um, Logistics is important. Anything you design needs to be understood. So meaning the layout of the site needs to consider from the beginning where to park, where to put the crane, where to park the delivery of the prefabricated components so they can be lifted, how things can be staged. You've got a lot of components coming through, and if they cannot be installed quickly, then that gets costly, right? So that idea of logistics planning needs to be understood well. Site install is something that happens magically and very, very fast if everything is in place, right? So really, cycle times can be if we have done sort of takt time measurements right now, and if everything goes exactly to plan, which takes time and certainly doesn't happen on the first project, not on our first projects, but if you simply measure the cycle times of if everything is pre-staged, meaning your construction financing also allows for the manufacturing in time, the cash flow of the prefab company, everything can be put in a staged area. You can do a nine-story building in 30 days, right? To enclosure. And that is the game changer. That makes everything different, right? Where you built your core up first in concrete or steel, and then you follow up with these kind of components and you're out of the weather. You essentially have a full structure that's fire rated and meeting passive house standards in 30, even by today's standard where we're at right now, call it 60 days. It's possible that it's not fantasy. Um, so I think that's really important. So it's before I close here in about 5 to 10 minutes, and welcome your question. Just want to share some sort of lessons learned. So we really need to overlap design, manufacturing, and site work to enable faster erection times and consistency in what can be manufactured and how it comes together, um, and reduce, any delays that, particularly in Ontario, of course, now you have the winter, so we're trying everything to get the building completely enclosed just before the holidays. We're almost there. We're almost up right now. I'll show you one more picture, like where does it look right now, in just a moment. Just a reminder, like CSA certification, you see these stickers on these parts. It's in many ways provides a lot more peace of mind. So I think work with your suppliers in the future that they get certifications on their factories and their components because it means that they have gone through a rigorous quality control process overall, and that you have something you can rely on. The building inspectors can, the owners can. That you also have the quality control, so you don't need any rework on site, and so forth. It just provides a lot more certainty around everything. Um, it is possible to really dramatically change the carbon footprint of a building like this one proves it, right? It's not a dream. You can have all this now exposed. So you also save on the drywall and money and overall carbon and emissions and time. And you don't have to build it in concrete, right? There are systems available right now to the industry where you can do this and you can work with the systems and getting them very comfortable. And we're surprised how well the cities and the buildings officials' offices have made no issue about this building. Um, our requirement, our request to have the timber fully exposed, because maybe quick background, I'm sure if you're all aware, but right now under the regulation, you can build up to 8 stories under the Canadian Building Code, right? The maximum building code up to 8 stories without drywall, up to 12 stories with a certain amount, and then above 12 stories, no exposure. Now here we have it all exposed. The building I showed in Kelowna will have all its ceiling exposed, even at 18 stories. So we find the chief buildings officials very receptive. They understand that there is real benefits, and the fire performance of mass timber is actually outstanding. Um, Now, as an architect, it's nice to sort of draw grids and so forth, but the devil is always in the details, and it's all in the connections. I'd say that's what I tell my team all the time, right? Anything that cuts through the mass timber, anything that connects to it, the location, the positioning, and all of it, it's all different than what you have in a conventional concrete building or conventional construction. So that is where you have to dive in and really understand all the penetrations, all the fire issues that are there, the fire stopping where necessary, placement of walls, acoustic, flanking noise issues, and so forth, right? So those details need to be understood. Again, customization is possible by using advanced manufacturing processes, and most manufacturers are open to that if you can drive that. If you just come with a wild design and let them figure it out, that will just give you a really high price. You have to come with a logic as to how you take advantage of the manufacturing that they have available. So it's designed for manufacturing, not as an ambition, but with a resolution, with a solution that you bring to the table as designers or that we do as architects, right? Challenges with all these buildings is moisture management. So and Taunton City thought we'd done a good job, LWPAC done a good job, and all of a sudden you've got like horizontal rainstorms, etc. Everything gets wet. That's inevitable, but you have to design for it, right? So the where's the building, where's this piling up? How do you get the water out of it? What do you make sure it doesn't get into the assemblies if you already have finishes on the lower floors? How do you funnel the water through the building? In this case, we have a floor cassette with insulation, so even in the detailing of everything, in Taunton City does a good job. LWPAC sort of forced some more, on making sure we don't have like standing water getting into insulated cavities and so forth, right? Rather, how can a building like this drain out, can be dry? What if there's ever a sprinkler event or so? So that question, I think, will always come, and you have to have a good solution to that. What can we do differently in a building like this? I think not just bring the team together as early as possible in terms of architects and engineers and manufacturers and builders and developers, and see this really as a team effort, but also bring key trades in, like mechanical, electrical are very, very important. If there's any need for comfort to build and test mockups, do it early. Understand what you really want to test, maybe where you can get a little bit of funding from the governments to do this. Standardize as much as possible. Really just don't have any unnecessary variation. Have the variation where they matter to your design. Don't just have variation for the sake of it. That's just every variation is a cost issue when you're trying to work with a manufacturer and a systems build approach. These factories want to output 1,000 homes of the same, ideally, right? And so with any requirement for customization, it requires extra thinking, and it has to work with what they can do. Um, so we're really interested, and this is how where the building is right now. It's actually just had a few more facade panels now on the seventh floor installed now, and it's about to top out on the structure, but the service is already in all the way to the fifth floor. So everything follows up really, really quickly. So goal is to get it enclosed in the next few weeks, and then have it open by Q2 of next year. There's sort of a little side thing for myself. This is the view from the ninth floor common amenity space. If you do urban densification along the urban arteries, you sort of democratize the sky because anything around you, anything adjacent is often very low scale. So people get quite nice homes and quite nice views. They get this sort of possibility to live with this beautiful mass timber overall. And then, obviously there is this possibility to really have a strong conversation with the regulators, which we've had in Vancouver, in Kelowna, in Toronto. It's been very encouraging to really talk about how we can make the entitlement processes better, approval processes better. And I really can't complain. I think the cities have really been partners in this. There are, of course, questions about, how do we take a building like we're doing right now and put it on a wider site? What do you do with this zoning issue when you go above 60 units in Toronto? You probably know about. So those things need to be addressed so we can do more urban infill. But for the messages that we have for owners and developers is to lower risk in these buildings, more predictable systems and schedules, much better product quality, no doubt. When you see how these windows are installed, right? It's like a very tight, gasket around these windows that have been quality controlled in a factory. It's just always the same gap, right? And so the quality overall, the tenant experience in terms of acoustic comfort, climate comfort, is really exceptional. you have the ESG story, the potential premiums because of the biophilic aspect of these buildings, and then long-term asset value and resilience of these buildings should be excellent. Um, how can one work together? Again, I think build your team. I think in the way how we're building teams now is not just going to be just an architect and a structural engineer and building envelope consultant and co-consultant. It's really what is the team that is required to do buildings that use systems. So who's the systems expert? Who's the mass timber expert? Right? Who is the architect of record? Who's the planner? Who's the client interface, etc. The roles become more diverse and I think increasingly require teams to be built around that expertise. And again, we as LWPAC are just completely open to collaborate with any architect right now and share our knowledge there and collaborate. I think that's just necessary to change the industry. We need to provide, we need to have an attitude of collaboration with builders, with suppliers, with the cities and so forth. And we are very active in providing advisory for the cities, for governments. I'm serving Canadian on the BC Woodworks BC, Canadian Wood Council, also on a committee from the government about, as actually from the steel sector to create steel timber hybrid buildings. And frankly, in many ways, the building I showed you in Kelowna is already a steel timber hybrid. So steel structures, steel columns, steel connectors, mass timber slabs. And concrete cores, but some of the cores will also be transformed step by step, I think, into steel, where and when they are available. We form increasingly groups, I think, with like indigenous groups and a nonprofit sector right now. Yeah, so these are very important. So to build more of these, we believe mass timber is now ready for prime time. We've proven this now on two projects to ourselves, two nine-story buildings, and everything has come together exactly as we expected. And it didn't really surprise us. I started using, advanced 3D CAD files back then when I was a young architect in New York in the 90s, and we would take out math and calculations out of 3D files and sent them to steel manufacturers, and they put several thousand pieces of steel together, and they all fit, right? There was no surprise with this, and so taking things towards a system, taking things towards a factory, really simply enables what's been done in the past, right? And people use good math to fly people to the moon in the 60s. I think we can use some good math and physics now to use systems approaches in the way how we build buildings without thinking that we're taking, undue risks. So I think we're just simply doing what's possible within our fields. And so we're looking forward to collaborate with any one of you and yep, open to our question. Thank you very much.
Okay, great. Thank you so much, Oliver, for that really excellent presentation. I know there's a lot of questions already in the Q&A, so I want to jump right in. I want to start with, I did see a few questions about whether the slides and the materials will be shared. So unfortunately, Oliver is not able to share the slides with you, but the OAA is recording this presentation and it will be made available on our YouTube page after the holiday season. So please look out for that. And then I saw a few questions here that are related to cost. So I thought we could maybe bundle those together. So a few have asked how the cost compares to, for example, building cast in place concrete structures, and also how it compares to traditional steel and wood construction. So maybe Oliver, if you could answer those questions.
Yeah, so I'm going to respond to this in the context that these buildings are in 9 to 18 stories. We've done a lot of costing exercise, and right now, in this market right now, we see pretty much cost parity right now. One pricing is $2 a square foot more here, one is $5 less there. It really depends a little bit on the project and the contractor you talk to, but they're pretty much a match right now, and so that's increasingly disappearing as sort of holding it back. But I think that situation is also not a perfectly accurate reflection because we were already sort of if you would ask me that a year ago, we would have been 5% better. But the market has dropped for conventional construction currently. So we see that momentary dip, but we think that in a year or so, when projects that are being planned now are going under construction, you'll see a lot of that being reversed out because you'll have, once projects are picking up again, you'll have a lot of projects coming back on stream, and then the labor shortages that are there will only be exacerbated. And so I think then you will see concrete buildings and custom buildings with long cycle times to get them built becoming more expensive again, right? But and then so that's one thing, is where are we on a one-on-one comparison? The other issue, and Intelligent City's done extensive studies on this, and so I think has the Canadian government and so forth, is that if you use a systems approach and you get repetition and you can use it consistently, prices on at least what I'm showing you for this, the enclosure and the superstructure, and then hopefully in the future also on the mechanical, electrical systems and so forth, can come down significantly. We're not afraid to say that within, 4 or 5 years or so, to see these prefabricated systems to come down in pricing 15 or 20% from where they are today, right? So overall, is it possible to get prefabricated buildings down by, let's say, 5%, maybe 10% to where they are today? I think that is possible, while current pricing on buildings might well be 5 or 10% higher. So fast forward 3 years, there could be a 20% gap between the two, right? That's speculation. I understand that. But it's also looking at trends that we've been following for the last 20 years and sort of see where are we really, and what we think would likely happen. And I think we have some experts in the industry that we've been talking to that confirm those trends.
Okay, great. Um, we have a question here about the manufacturing. So someone has asked, are all the components manufactured in Canada?
This is all manufactured right now in BC and then shipped out to Ontario. Town City has a plan to have a facility in Toronto online, subject to funding and financing. And there's lots of discussions with the province and the federal government and investors. But the goal is to have a larger manufacturing facility in Ontario. And yes, all the components are machine manufactured, assembled in Canada. Yeah.
Great. We have a question from Khaled here who asks, you mentioned a mass timber consultant. Would that be someone like you? Do fabricators of the prefab panels provide this service? And would the panels and members be designed on Revit or something else?
Yeah. So LWPAC offers that, like engineering firms, building science firms offer, let's say, building envelope consultancy. LWPAC offers a mass timber consultancy, right? So if you're not yet feel not sufficiently familiar, but you'd really like to get into it, LWPAC has just a ton of experience of how to do that right and come on board and be sort of work along your side. And yes, everything is prepared in Revit.
Oh, Revit, sorry. Thank you. We have a question here. So this is in light of recent fire in high-rise residential buildings, how is a fire stop achieved at the meeting of a floor slab and exterior wall?
It's a fully Hilti approved fire stopping solution. It's pretty conventional. So the mass timber and in the floors and in the walls have their own rating. And then as the fire stop installed, it's basically installed from the top with the Hilti solution that has a full engineering certificate, and then everything is filled with mineral wool up on top and bottom, and it nearly impossible any fire to get through that, right? And again, we've tested the panels in themselves just to make sure how that works. We even tested the panels with penetrations and see what's the flame spread relative to mineral wool conditions and so forth. And as an architect, who signed and sealed for this, I feel you know always asking many questions and making sure, but within the industry standard, to the best of the knowledge of our industry and our profession, I was comfortable to sign and seal for this building. Yeah.
Great, thank you. We have another question here. So you mentioned that during a project, LWPAC owns the full, Revit model, all disciplines. Can you elaborate on the workflow/coordination process with your external disciplines? They mentioned in brackets here, Struct and MEP, and how this impacts your fee structure as an architect.
Yeah, so we've tiered our fee structure as sort of, let's say, standard architectural services, specific effort around mass timber integration, specific effort around, managing and holding the BIM model and creating additional coordination and integration meetings and so forth. So just that our clients can see it, because otherwise you just go in and you have a fee and it looks much bigger, and somebody comes in on a project and whatever, low fee that are in the markets. Um, but I think it's very important to have a conversation with your client, that they understand that they get what they pay for, and if they do not pay for proper coordination, they'll just simply pay 5 times as much for fixing things later in the factory somewhere, or having things remade or installed incorrectly on site, and so forth. So that's a precondition for a good client. And I wouldn't work on this with bad clients. They need to want this and understand it, is that there is an extra effort being made, and that's part of the what I would call like sort of the pre-construction phase and fee, right? You really enable that. Yeah, sorry, what that was the second part to the question. One was how you structure the proposal, and what was the second part?
Um, so it was, can you elaborate on the workflow/coordination
Oh
process
yeah.
with your external disciplines?
Yeah, so I mean, it's basically the LWPAC architects would hold the model, and then we will, cycle it through with the structural engineer. We cycle it through with the MEP consultant. We have them mock it up. We have them specify and install certain things. We then verify on clash issues, on making sure that that's all coordinated. Not every mechanical engineer is perfectly equipped to have a sophisticated BIM model. They often tend to draw symbols in 2D. So this is something then where LWPAC will pick it up, and then you also need to, of course, have a manufacturer chosen eventually. Now the question is really, who do you work with and what process do you go through? If you decide on your system supplier early, that is very, very helpful. Sometimes there are questions around, procurement, tendering, and the public sector projects and so forth. Then it's even more so important that the architect has done as much coordination as possible, so that the scope is crystal clear of what needs to be done. So a lot of collaboration, moving the models back and forth and so forth, but somebody has to hold it and be responsible. And in our case, that's almost always us. Right?
Great. We have another question related to fire resistance here. So, if you have a new project with new wall prefab assembly, floor slab, and beam type, do you need a new laboratory testing for the 2-hour fire resistant requirement and get a new certificate?
It's a question, if you have a system that is unique to the market, or you come up with the system yourself or together with the team, then yes. But you can, of course, also simply rely on, let's say, a typical 175 millimeter slab can span a certain amount and have a 2-hour char rate on it, right? So the rule of thumb is there that you end up somewhere between, let's say, around 42, 43 millimeters an hour of char layers, a sacrificial layer that's included in the engineering. And so you can work it through with your engineer, with your structural engineer, where the stresses are and what must be left over after an hour or after 2 hours of fire, and then just install a standard slab. If you have columns and beams, then those need to be clad and fire separated. And so you'll just go simply through every single part by itself, having the fire seal on themselves and not rated into it. The rating comes really from the standard materials, right? Versus in the systems approach, you want to make sure, like in the Telton City floor cassette, the 2 hours have been tested. That's in the certificate. So you really don't have to do anything about it other than fire stopping panel to panel.
Okay, great. We have a question here. So Catherine says, it's great that the wood elements could remain exposed. However, I'm curious if there were any issues with enclosed timber in a bulkhead, for example. Did these areas need special consideration or are they fine to just be cladded over?
If it's just stresses or something like that that are there and you just need it for additional fire safety, you can just clad them over. If you have bulkheads, you have to, talk it through with your co-consultant in the city if sprinklering is required in a cavity. Typically in mass timber construction, all cavities need to have sprinkler protection. So now it's just a question, have you provided the fire separation directly under the mass timber, or is the bulkhead providing the fire protection? If the fire bulkhead provides the fire protection, then the cavity typically in a high-rise application, so it falls under the mass timber code, so anything above 7 stories, 7 and up, um, would be sprinklered.
Okay. Um, Here's a question that says, how is STC on sound determined? Does the supplier provide a certification?
A non-system supply would not. That is something you have to work through with your acoustic engineer. If you have a systems like the Intelligent City floor system, for example, that's tested, so it comes with a full set of guidance on it, STC 55 on sound separation, and then if you have to have extensive discussion about flanking noise. So, for example, if you have, the facade panels, for example, on the 230 Royal York project, are split at every unit. So if the home is 2 bays wide, it's a 2 bedroom, then the facade panel spans the whole 26 feet across or 27 feet across. But if it's a studio, then the facade panel spans only one, just to simply avoid flanking noise from through the sort of exposed timber curtain wall, right? On the floor systems, it has a layup overall on acoustic issues on top of the because you need gypcrete or concrete on top of it anyways under the mass timber regulation for high rise, and then there's a acoustic separation layer in between, and that gives you certain flexibility. So, sometimes you cross over the grids, and depending on the type of room and function, that's typically acceptable. You don't want to be undisciplined with that, but you can do it. But on a panel by panel basis, there is on the intelligent city system, there is a testing certificate, and any other systems you'll have to inquire. Um, but typically you would go in and create that through a review with your acoustic engineer if you do generic mass timber construction.
Okay. Um, there's another question here. So, if the exterior walls are not load bearing, what was the rationale to use solid CLT for the panels rather than LWF?
It's just consistency, strength, simplicity in the manufacturing process. So these panels are just holding up to significant wind loads, and any lateral drift in a seismic event, and so forth. So they're really high strength components. Simplicity of manufacturing using the robotics, you can just pick up one panel and drop it in and you're done versus lots of small little things. So it's a trade-off between sort of the amount of fiber and the elements you install versus the sort of more simplicity of the system. And Intelligent City, I think we're still very happy with that choice.
We have a question here about the wood specifically that's used. So, what wood species are typically used in mass timber components, and how does that change with the location?
Yeah, I mean, it's just like in North America, you still use SPF, so standard, and it gets sorted depending on the strength classifications that you want, what the layup is in it, and you can discuss that with the manufacturers, but we have mixed forest here, and that is really, the SPF is really what's being used, depending on the manufacturer. If it comes out of Quebec, if it comes out of Ontario, if it comes out of BC, Depends a little bit, but it's just, the species that we have available.
Great. So we have just a few minutes left, I'm noticing. I don't know if we'll be able to get to everyone's questions, but hopefully, if you do have a question that's not answered, you can reach out to Oliver to get your answer. But there's two sort of similar questions that I think would be nice to end on. One is asking, do you see the chance for modular system being used in small scale projects like multiplexes? And then another question is asking, or well, the first comment is that prefabrication with mass timber and systems thinking makes all the sense in the world. What barriers exist to its adoption?
Mhm. Um, I would say we've overcome a lot of barriers on the regulatory side ever since I've been trying to push some doors open for the last 20 years. Um, the key barriers right now are really the financing tools that are out there. So we need to find ways for the funders of the underwriters of public projects, public programs to understand that if you want to create a $1 billion prefab industry, you can't expect that industry to have $1 billion of equity sitting on the bank account to procure materials in advance and then fund it during construction and then get paid when the parts get installed on site. That's just not feasible, right? So we need to have some banking partners. Some of the big banks have to step forward and understand that and help de-risk the whole thing. And I think some are. They're trying. Um, and we need the governments to come in and not provide the equity necessarily, but provide the underwriting. Um, that goes from bonding, working capital issues for the prefab industry, the whole, cash flow that ultimately a prefab company should be able to, by the time it orders the material, it can have a draw on the order. By the time it's manufactured, a product goes from left to right to the factory, and within those 4 days, it puts it out the door. It gets put into a specific area. It can have a drawer. So financial needs are significant in all of this, and they must be addressed so that the industry can scale and then through scale push the costs down. I think that's number one. Number two is really, have all the cities making sure that they really allow us to have that they have an understanding that when you do the same, if we do take this 230 Royal York project and move it down the street 3 blocks over and saying we're going to do the same project, right? Why would I wait for a site plan approval? Why would I wait for a building permit? I should get that within a matter of days, not weeks or months, days, because it's the same, right? So I show them that the soil conditions are not different. I show them not that I'm meeting all the other requirements. So if approvals are fast, we can de-risk it for our clients. And because the systems approach can give us that certainty that you can't do with a typical building, um, allow for that implementation, right? So we're working hard, and I hope all of you can join me to convince the regulators to work with us on that side as well. Um, we need to build an ecosystem. So it's not just us, like Intelligence City cannot succeed by itself. LWPAC cannot succeed by itself. We need broad adoption. The broader the adoptions, we're cheering everybody on that builds a mass timber building right now, because that's good for the industry, right? So we need more of those so that people don't look at this as an outlier, as a unique thing, or that they think there's something to worry about. I can tell you with the experience that I've had now with these buildings that we have done over the years, every single time I have prefab, I sleep so much better as an architect with the liability that you have than the chaos on site when you've done something as, sort of on a more conventional way and of the change orders and the stress and tensions that creates.
Great. And there was another question related. So, asking, do you see the chance for modular systems being used in small scale projects like multiplexes? And maybe you can also talk about sort of your future aspirations or where you see future applications for the kind of systems approach that you're talking about.
Yeah, I mean we've designed it really. Those systems you see here, along urban arteries, allowed sort of transit nodes. We've worked with some large developers on doing, a sort of a master plan study with them. What does it mean to use systems like this when you build 6,000 homes, and when you go from 40-story concrete and you push this down with the expectation of the same scale, the same density, call it an FSR of 6, 7 on average, right? What would these communities look like if you keep it in that like 8 to 18-story range? And I think that was very promising. So we really hope to do more of these. We're working with Indigenous group right now to roll out sort of more of this portfolio approach because they have lots of needs and access to funding and so forth. And that's very exciting to create meaningful housing for those groups. So sort of the taking the sort of more portfolio-based approach and building buildings consistently over a number of years, I think is a uh, very powerful area that Intelligent City is very interested in, and we're at LWPAC equally excited about. And then, yeah, I mean, take it into the smaller scale. Um, I think there's a lot of work to be done on the mass timber side that at least at LWPAC we're very interested and excited in to look at generally not just mass timber, but just simply engineered timber solutions to make them extremely cost effective because there's an opportunity in the up to 6-story market, right, where it's not high rise and therefore it's less onerous in terms of firefighting, in terms of fire code. It's 1 hour instead of 2 hour separation. You don't need a whole bunch of things that are required under the Mass Timber Code, and 6-story slab on grade buildings of a certain kind, maybe not as urban, more suburban. That's definitely something we're looking into. Taking the systems sort of building there. There are people have approached us, and at LWPAC, we've now started a series sort of projects, and this whole idea of all the single family lots been converted, as you probably heard, a regulation here in BC where everything is now allowed to be 4 and 6 plexus. So we have some projects there right now and seeing can be systems built those sort of 4 and 6 plexus and create meaningful density on single family lots. Could be significant. So we're looking at that. We have these projects, we're working through it, but that's sort of a new market segment, and it's early stages, and we want to look at it very carefully what the right methods are. But we have, of course, 20 years of knowledge of systems thinking, and see what we can bring to that sector.
Hey, great. Thank you so much, Oliver. Thank you for everyone who submitted your questions. Again, I apologize if we didn't get to your question today, but I think, Oliver, you had your contact information on the slides there. So if anyone would like to reach out, please do. I have just a few closing announcements before we end off for today. Again, for those of you who are seeking your continuing education hours, the OAA will record your participation in this webinar on your transcript, so there's no need for individual reporting on your part. We just kindly ask for some patience at this very busy time of year as we work to process and confirm the accreditation of your hours within the next few weeks. Again, we are not sending out the slides for this presentation, but you will receive a link to a survey where you can submit your feedback for Oliver, and we really appreciate that, and I'm sure our presenters appreciate that as well. So please, if you get a chance, take a few minutes to complete that survey. Again, the recording will be made available on YouTube in the coming weeks. And then finally, this is, as I mentioned, our last webinar for 2025. So our first webinar for 2026 is going to take place on January 15th. And this one is going to be hosted by the continuing education team with the title Introduction to the OAA Continuing Education Program. So in this webinar, we're going to be talking about the benefits of participating in the Con Ed program. And we're also going to be covering topics like updating your transcript and the OAA's new auditing model. So registration for this webinar is now open. So please be sure to sign up so you don't miss this very important information as we move towards the end of cycle next year. So with that, I will thank Oliver again for your excellent presentation. Thank you to all of our attendees for your participation as well. And we look forward to welcoming you back to the webinar series in 2026. So thank you very much and have a pleasant remainder of your day. Thank you.
Thank you very much. Thanks for having me.